This is the last lecture of the year, no pun intended. It's been fun year, very interesting and very different. I hope you all will come say hi next year. Today we're doing 12.2, the final day. And for those of you going on to calculus, this is just going to lead right into it. We're covering examples 4 and 5 and a little bit of 6, but not really. Our goal, should you choose to accept for your final mission, is that you will be able to rationalize indeterminate forms of functions and find the Harry. Find the of polynomial functions at infinity. We're also going to look at rational functions, but we're just going to kind of keep it in the same guise as we've done before. But so if you'll recall yesterday, if we ended up with something that, say, the limit as x approaches 4 of the square root of x minus 2 over x minus 4, our first step is to do direct substitution if possible. And we get the square root of 4 minus 2 over 4 minus 4, which ends up with 0 over 0, which is the indeterminate form. And the indeterminate form means there's something else we can do. And so this is the case where when we have these rational functions, and I can't factor, I'm going to multiply by the conjugate. And I'm not going to multiply by the conjugate of the denominator because it's this radical I want to get rid of. So I'm going to, great choice of pens. I'm going to multiply by the square root of x plus 2 on both sides. So when you multiply by the conjugate, you're going to always want to do the conjugate of the function that has the radical in it. And so then this turns into the square root of x squared minus 2 root x plus, I don't know why I'm writing this out, true root x minus 4 all over x minus 4 and the square root of x plus 2. I don't want to simplify this because this turns into the square root of x squared is x. These go away. X minus 4 over x minus 4 times the square root of x plus 2. And now we can simplify that to get 1 over the square root of x plus 2. And so once we get that, I mean, we could rationalize that, but we don't need to because we're looking for the limit. So to do this, we now just take the limit as x approaches 4 of 1 over the square root of 4 plus 2 and simplify. And so 1 over 2 plus 2, it equals 1/4. And so we want to make sure on your quiz, a lot of you guys didn't write your final answer as limit. So I'm going to make sure I model that. The limit as x approaches 4 of 1 over, the square root of x minus 2 over x minus 4 equals 1/4. And so there you go. I'm going to give you one your turn here. I would like you to find the limit as x approaches 25 of x minus 25 over the square root of x minus 5. Okay, so hopefully you did it. Step 1, you plug 25 in, you get 25 minus 25 over square root of 25 minus 5, and sure enough, that's 0 over 0. Shouldn't really be a shock because, well, it's your turn. So now we're going to multiply by the conjugate of the denominator. And so we'll do like what we did before. And we'll multiply by the square root of x plus 5 and the square root of x plus 5. And we're not going to multiply the top out. We'll leave this as x minus 25 and the square root of x plus 5 because we learned that trick from Miss Dunbar prior. And when you multiply this out, it ends up with x minus 25, which simplifies to be the square root of x plus 5. So now we can take the limit as x approaches 25 of the square root of x plus 5, and we get the square root of 25 plus 5, which is 5 plus 5, which is 10. And so our final answer would be the limit as x approaches 25 of x minus 25 over the square root of x minus 5 equals 10. And so that is how you solve those. Remember, whenever you get 0 over 0, there is a limit. If you were to get 7 over 0, something's going on there. So 0 over 0 is the indeterminate form, and you can either find the limits by multiplying by the conjugate or factoring. Okay, so now we're going to look at finding the limits of polynomial. And if you'll recall, I really, don't think I'm on the screen, and I'm not. If we have even powered functions and our a was positive, the graph kind of went like this. And this is f of x equals x to the n, where n is even. And this would be f of x equals x to the n, where n is odd. And so our limits of these functions, the limit as x approached negative infinity, f of x approached infinity, then the limit as x approached infinity, f of x approached negative infinity. Here, the limit as x approached negative infinity, f of x approached negative infinity, and the limit as x approached infinity, f of x approached infinity. And so these were for even powered functions and odd powered functions. And so when we are looking at polynomial functions, so when looking at polynomial functions, and if we're looking at the end behavior, so going to infinity or negative infinity, we look only at the sign and degree of the leading coefficient. We ignore the rest. Okay. Ignore with an M? I don't know. You're welcome. I'm on fire today, guys. It's probably because I'm doing this in the morning and I just had coffee. So, we'll look at one. We want to look as x approaches infinity of 2x cubed minus 3x to the 5th plus 4x to the 6th. So, first we're going to identify the leading coefficient. And it is 4x to the 6th. So, our next step is we're looking as x approaches infinity of 4x to the 6th. And then 4 we bring in front. 4, and then x approaches infinity of x to the 6th. This is even. An even function goes off to infinity, and this is positive, so 4 times infinity equals infinity. Therefore, the limit as x approaches infinity of 2x cubed minus 3x to the 5th plus 4x to the 6th equals infinity. And you maybe could tell that from here, from the very beginning, but if we asked you to show work, this is where you would go. And most of it we will. I'm going to give you a 1 year turn, and we're going to call this a day or a year, as that's it. So let's try the limit as x goes to negative infinity of 2x cubed minus 3x to the fourth plus 1. All right, so first, negative 3x to the fourth is going to be our jam. So limit as x is negative infinity of negative 3x to the fourth. So we take this negative 3 in front. Should have done odd. I don't know what I was thinking. Of x to the fourth. So that would be negative 3 times infinity, which is negative, essentially infinity. So our answer is the limit as x approaches negative infinity of 2x cubed minus 3x to the fourth plus 1 is negative infinity. And that's it. All right. Have a good day.